Hello, my name is James Inciardi. This is my PowerPoint presentation about work of breathing. Since we're talking about work of breathing, I decided to put a bunch of pictures up of workers on my PowerPoint. I figure we can only talk about diaphragms and rib cages and pictures of all those things for so long before we all get sick of it. All right, so let's get started. Here are my objectives. State the difference between work of breathing and effort of breathing. State the role of airway resistance and the role it plays on the work being done in the lungs. And state how to mathematically show that the diaphragm is or is not fatigued. Okay? So here's a key point. Is work of breathing the same thing as effort to breathe? Well, is it? I think most respiratory therapists would say no, it's not the same thing. But why not? Well, let's have a look into that. What is work? Okay, I'm going to get into physics in this PowerPoint, but only for a few seconds. Don't worry, just a few seconds. Work equals force times distance. So here's a little picture that I made to help remember that. If we look at this crane here, we see that I labeled the parts of the crane to help you remember. I should clarify that in tower cranes like this one, the motor is located on the PowerPoint. It's like back here. Okay. I didn't know that, and I had to look it up, and I bet you didn't know that either. So you can't say you didn't learn something from my PowerPoint. The work done on this beam, the work is this beam right here. The distance that it's going, the distance in elevation, and the motor is generating the force. Okay? So, let's say that this construction crane is trying to lift this concrete block, but the block is too heavy. Is any work being done? No work is being done. No distance is being covered. So there's no work being done. No matter how great the force, if this block doesn't move, then no work is being done. Oh, okay, all right. I'll get to the point. Okay, if we wanted to calculate work of breathing, here's how we would do it. Now I'm going to tell you the equation, but don't write this down. Just listen for a minute first, okay? Now, work is usually measured in we usually measure work in kilograms multiplied by meters. So to calculate work of breathing, we would substitute pressure for force and lung volume for distance. So we would come up with work of breathing equals pressure times volume. Mechanical work is usually expressed in joules. So to convert to joules, you divide centimeters of water by 10. So the normal work of breathing is usually around 0.5 joules per liter. So there you go. That's how you calculate work of breathing. However, work of breathing is, well, it's not a very useful measure. Well, think about it. That wasn't a very complicated calculation, was it? If it were really useful, wouldn't we be calculating work of breathing all the time? Wouldn't they have a work of breathing numeric on the ventilator? And they don't, do they? Because it's not useful. Well, really, on the ventilator, you have volume, you have pressure, you have rate. Those figures tell you enough about how much work is taking place. And the amount of joules that are being used in each breath really doesn't matter. If you're not doing indirect calorimetry, maybe it'll matter then. But that's pretty uncommon. So, no, you don't need to know the work of breathing. What you want to know is effort of breathing. So you say, great, well, what's the equation for that? And, well, in your typical ICU patient, there is no such equation, unfortunately. Sorry about that. Yeah. However, you're not out of luck. There are some things we can do to determine the effort of breathing. As you know, the diaphragm is the primary muscle for breathing. But it has some special characteristics that you might not be aware of. Firstly, it has a greater proportion of fatigue-resistant type 1 muscle fibers, so it can keep operating while the rest of the body will tire out. Secondly, the muscle has increased mitochondrial density, increased oxidative capacity, and maximal oxygen consumption. Thirdly, it has an increased capillary density that facilitates more efficient O2 diffusion. So the diaphragm is well suited to its role as the primary muscle for ventilation. But if you've been a respiratory therapist for any amount of time, you know that the diaphragm is not invincible. It will fatigue when a load is placed upon it that's too great. What load, you ask? Well, let's look at a familiar graph that we've seen in this class before. This one. Remember this graph? Now in this graph here, this area, which I'll call the trapezoid, this here, that, the trapezoid represents the effort required for breathing. The greater the area of the trapezoid, the more effort is required to breathe. Okay? Now, in this theoretical graph, there is no airway resistance. Of course, we know that can never really happen, but if there was no airway resistance, the trapezoid would look like this. Okay? There, no airway resistance, so just go straight up there, and like that. Okay? And also notice that on exhalation, when there's no work being done because of passive motion, it comes in like this, showing that the trapezoid is smaller in area because this is not work, it's just a passive motion. Okay? Now in this graph, we see increased airway resistance. There can be a number of reasons for this, but the bottom line is that the diaphragm is being asked to do too much work. Although I said the diaphragm was well suited to its job, the load we're asking it to do is just too great. And that leads me to a term which is important: overt fatigue. Overt fatigue is defined as the inability of the diaphragm to sustain a given force of contraction throughout inspiration. Okay? So, how do we measure and figure out that the diaphragm is failing? Well, the gold standard for determining that is the tension time index of the diaphragm. Unfortunately, that's pretty hard to figure that out. You have to get esophageal and gastric balloons in the patient, and let's face it, no one's really going to do that. But we do have tension time index of the inspiratory muscles. Sometimes it's called the pressure time index or the PTI. This figure correlates closely with the tension time index of the diaphragm. So let's go with the tension time index of the inspiratory muscles instead, because we can get that, it's easier. Take a look at these definitions here, okay? First, we have PI, and as you see there on the slide, that's the mean inspiratory pressure. To get this, what you have to do is, what you can do is just put the patient on expiratory hold and see what pressure he inhales at. There's also a way to do this by getting the PO1, but that's complicated. Let's just stick with the basics, the easy stuff. Then we have the PI max, which is the same thing as a NIF. The negative inspiratory force. A spontaneously breathing awake patient can provide all of those things for you. Okay, so then you look at the TI-TOT. And then you plug them into this equation and you get the TT-MUS. The normal TT-MUS is around 0.05 for a normal, healthy breathing person. But if you're looking for a critical range to extubate, a number lower than 0.27 is good. A number between 0.27 and 0.43 is questionable, and a number higher than 0.43 suggests diaphragmatic fatigue. So extubation in that case is might not be such a great idea. Oh, now it's time for a pop quiz. Don't worry, this quiz is easy. 3 questions and I'll be all done. Okay? What is work? I bet this guy doesn't know what work is. Anyway, work equals blank times blank. Is it force times distance? Is it distance times speed? Is it mass times force? Or are you just looking at the picture? Well, the correct answer is A, although if you were just looking at the picture, then at least I can say you were honest. Next question, what does this slide represent? Does it represent increased airway resistance, decreased airway resistance, no airway resistance, or can I go back to the picture of the good-looking construction worker? And the answer is C, no airway resistance. Here's a picture of the original slide, where if it were just a normal lung. Okay. And lastly, why is work of breathing less important than effort of breathing? Which, I covered that. Well, it's because, taken literally, work equals force times distance, and then we have to give the answer in joules, and that's not very important to everyday respiratory therapy. On the other hand, effort of breathing is important. That tells us how hard it is for the patient to breathe. If the diaphragm reaches overt fatigue, then it's not able to contract adequately to sustain the patient. All right. And thank you very much. That was my PowerPoint presentation. If you have any questions, please feel free to email me. And there are my references. And thank you for paying attention. Take care. Happy respiratory therapying.